Hello and welcome back to my RC channel. I'm Andy RC and today I'm doing another shot to flight video for a micro FPV quadcopter. A lot of you guys have watched my original micro quad build video, which was based around the Hubsan flight controller and the Hubsan 2 megapixel camera board. Today I'm going with a fully customizable setup. This video is going to showcase a lot of new components. Some I have been sent in for review and some I have bought with my own money. I know you guys enjoy seeing me shop for the components, so I'm going to keep that format the same. There are components that have not been used before in this build, so rather than this being a how-to video, it's going to be more of a log of the experience, which is how I formatted the Hubsan build as well. The parts I choose in this initial shot may change throughout the build, but I will advise of this when I do so. The first component I want to talk about is the flight controller board. I'm going to be using the much requested Scisky flight controller. I was first made aware of this controller board from my friend Alex, who was looking for an alternative to the Alienware and multi-flight board. To date, the Alienware is my favourite micro flight controller. It has been discontinued though for now. I'd love to see it come back. I took down my Alienware how-to video, but will put it back up if someone brings it back, as I put a lot of work into it. The Scisky board is available from Banggood and branded as Quantum. It is a cloned version of the board available from Oversky RC. It costs around 20 GBP and it boasts some interesting features. It's designed to be a brushed version of the Naze 32 flight controller used on many race quads, so of course it supports clean flight and base flight, which are really hot topics at the moment. Supposedly it has a built-in 5-volt regulator, which should be handy for our FPV rig if it works. It's got a built-in DSM-2 receiver. My only worry is that it has a very tiny, fragile copper antenna. I'm not sure on its range capabilities. One thing that amazed me about the Alienware was its range. The Scisky has a built-in mini B USB port, while at the same time managing to be tiny and lightweight. We are going to need to buy a lossy connector to attach to the flight controller. I find that the cheapest option is this Hubsan charging cable from Banggood. I can cut off one of the lossy connectors and then solder it to the board. The Scisky board has tiny pinhole solder pads to solder our motors to. The pinholes also allow me to add micro JST connectors direct to the board. I'm going to get some of these off eBay. That's because I'm going to be using motors from the micromotorwarehouse.com. I'm not sure which edition yet. I have a set of the Dark Edition motors and also the CL0820s. I'm leaning towards the Dark Edition motors though, as they seem to work well with my 750 mAh nanotech batteries. You can get those as well from hobbyking.com at a really cheap price. Remember to check the polarity is correct before plugging them in. I had to reverse all of mine. Onto the frame, and this is something completely new for me. This is a 3D printed frame from Thingiverse. This is where I need to give some important people some credit here. A friend of the channel, John, put me in contact with Lee from Painless 360. I'm sure a lot of you are already subscribed to Lee. If you are not, then check him out. He provides many how-to videos and reviews. Go and subscribe to him and check out his playlist section for his vast tutorials. I have used them many times. Lee of Painless 360 has started his video series on 3D printing, and he has very kindly printed me off this frame, which has been designed specifically for the Scisky controller board, as well as an FPV plate. Big thanks to Lee for printing this out and sending it to me free of charge. Lee advises that the material used is strong, but has a tendency to snap rather than bend when under pressure, so I do have a backup frame, which of course is one of the picnic quads, as used in my previous video. I'm going to need some vibration dampeners to attach the bottom plate to the top. You can get these off eBay. I already have some, however. For the props, I'm probably going to be using the stock Hubsan props or the clear Hubsan props. Both are really good. The clear ones are a little bit more durable. As this board uses DSM-2, I'm either going to use my Devo 7E, which I modded previously on the channel, or the Orange RX module in conjunction with my Taranis. Onto the FPV gear, the frame is designed for the Spectrum VA1100. However, I find this camera very expensive for what it is. It is a great all-in-one device, but the range on it is really poor. It claims to be 25 milliwatts, however, it's more than likely 10 milliwatts. Instead, I'm going to be using FPV Hobby's 5.8 GHz VTX in conjunction with their new 0.6 gram camera and their wide-angle lens. It's more expensive than the VA1100, but it should give us more range with its 100 milliwatts of power. The VTX features a micro cloverleaf antenna. The VTX has been sent to me by FPVhobby.com. Interestingly, the camera has been sent to me by microfpv.eu. FPV Hobby sent them a sample, and Rob, the owner of microfpv.eu, has sent this on to me to test it out. He has also sent me their wide-angle lens to try with it. So thanks to Rob from microfpv.eu, and also thanks to fpvhobby.com for providing the VTX. As this controller board has a 5V output, I shouldn't need a regulator for my FPV gear. However, I have a few of FPV Hobby's 5V regulators in stock if I need one. One thing I will need is a 4-pin JST connector to get that 5V output of the Scisky board. I will get some of these off eBay pre-crimped. For the video receiving gear, I will be using my Fat Shark Dominator V2s with a 5.8 GHz module and a cloverleaf antenna. Of course, you will need all the usual tools such as solder and a soldering iron, a hot glue gun, and potentially some double-sided tape. Oh, and time. Buy yourself a lot of time and patience too if you can afford it. I think that's pretty much everything, so onto the build. So I have sped up the assembly of this. It took around about 2 hours to get everything done, so I'm starting off with those 2-pin JST connectors. They slot into the solder pads really nicely. The spacing is perfect, and there was no dramas soldering them in either. We don't have any components that are close to the solder pads. Now, these JST connectors act as a mounting system for my VTX, and you'll see that later. So just soldering all those up there. And one thing you have to do is reverse the motor wires into their JST connectors. These are the motors from Micro Motor Warehouse. It's just the way the Scisky is wired. You don't need to do that with the Alienware, of course. So I'm just going to plug those motors in and make sure that they fit nice and snug. So the next thing is the Lossy connector. I'm cutting it away from its charging cable there and stripping the wires. The red wire is going to go into the VIN on the Scisky, that's voltage in, and the black wire is going to go into the ground. So I'm using my helping hand grips here, which are just a pair of pliers with a rubber band around them. I am holding the wire in place with the helping hands, and that is allowing me to solder it quite nicely. No real problems so far. Onto the FPV gear, and we have, of course, that 0.6 gram camera, the wide-angle lens, the VTX itself, and of course the cloverleaf antenna as well. We also need our 4-pin JST connector. I have had to remove 2 of the wires, of course, because we just need the voltage and the ground. I've also moved them down as well. That's just the way that the Scisky is wired again. So I am soldering in the voltage into the VTX. Now, the mistake that I made here is I should have twisted the camera's voltage and ground in with these and soldered them in as one. I didn't do that, which was a bit of a mistake, because now I have to solder those in separately, try and piggyback on the top of them, which is a really difficult job. So just make sure that you get those all in at the same time. You'll save yourself a lot of hassle. And then we have the video wire here, and that just soldered in nice and easy, no problems there at all. Again, using the helping hands there. Now, the camera was the worst thing to solder out of all of this. It is so tiny. You can see there that I have burnt the side of the casing of the camera. It is just so small, and those solder pads are just so close together. But luckily, I didn't damage the camera enough to affect it. It's just superficial, but you can see there, very badly burnt, but I have everything soldered in. The last thing to do is solder in the cloverleaf antenna. This one was really simple. You just got your 3 solder pads there and they just solder in nicely, no problems there at all. So you can see I have assembled everything to the quadcopter. I have hot glued in the camera to that bottom plate. I have also added the wide angle lens that just screws in and I have focused it. I have also added the blue vibration dampeners there. It's just a closer shot in there. And I have also added the VTX on the top. There's another angle of that in a moment. You can see I have plugged in the JST connector into the Scisky board as well, and that fits really nicely on the top there. The cloverleaf antenna doesn't get in the way of the props. I have also taken that 2.4 GHz antenna, the copper wire, and made it vertical. Next, I'm going to set up my transmitter in preparation for binding it with the Scisky. I'm using my Devo 7E here. Of course, you can use any DSM2 compatible transmitter. So I have created this model here, and we need to change a couple of things from the default settings. So I'm going to press enter there and go into the model menu and model setup. You can see I've called my model the Scisky there. If we scroll down, now we need to change the protocol to DSM2. We are not going to bind it yet because there's a couple of settings that we need to change within Clean Flight before we connect the battery up to the quadcopter. I have set the channel number to 10, so I'm going to exit out of there and we need to go down to the mixers. So what we need to do is change the weighting within the mixer. So if I go into throttle, we need to do that for every axis. If I scroll down, you can see here we've got the min limit of -150 and the max limit of 150. Now, if we use the default values here, we're not going to get the full resolution of the stick, so we need to change the scale to 147. The Clean Flight PWM values go from 1000 to 2000, and we're not going to get that full range if we keep the default values. So I want to exit out of there. We're going to want to do that for all these axes here, and you're also going to want to set up a channel 5, which I have got on the hold switch there, and a channel 6, which I have got on the F mode switch. Now I'm going to be using this to arm. Now you can use the rudder to arm if you like, but I like to have it on a switch, so I have set both of my switches up there. Another thing you're going to want to do is, if you're using the Devo 7E, is you're going to need to reverse a couple of the axes. Now, I don't think it's throttle. If we go into there, no, I see that says normal. I think it is aileron. So aileron is reversed. I don't think elevator is yet. Normal. And I think rudder is reversed. Yeah, so that's something that you need to do to ensure that everything is moving in the right direction when we go into Clean Flight. Next, I'm going to set up the Scisky board ready for its first flight. I'm going to install the Better Flight version of the firmware for Clean Flight. The reason for that is the 250 class racer guys rave about this version of the firmware and say that it's better than the Clean Flight firmware. So to get that, just Google Better Flight and it will get you to this GitHub website here, and if we scroll down to where it says Better Flight Nays, we want to download this hex file. That is because the Scisky is a brushed version of the Nays 32 controller board. So if you download that and just save it somewhere on your computer, and then what you'll need to do is in Google Chrome, if you don't use Google Chrome, you'll need to download Google Chrome, but then search for the Clean Flight app and you will be able to launch that directly from Google Chrome, and it will look something like this. Now, I have installed the VCP drivers from ftdichip.com. VCP stands for Virtual COM Port, and I'm not sure whether it's needed for this. However, when you are using COM ports, usually it is needed. So yeah, if you are struggling to get any kind of connection to the board, then you will need to go to ftdichip.com and download the VCP drivers. Now, if you have followed this build so far, you are going to want to remove that 4-pin JST connector from the regulator of the Scisky that is powering our FPV gear. The reason for that is we're going to have the USB connected into it, and that is going to power your FPV gear. And FPV gear does not like to be sitting there with no airflow over it. They get quite hot. So we're going to have the USB plugged in for a while here. So just unplug the power to your FPV gear and camera, and we are ready to go. Now, the Scisky board does come with CleanFlight already uploaded to it, but I, of course, am going to upload that Betaflight firmware. So what we need to do is go into the firmware flasher. And here you would normally choose your CleanFlight version of the firmware. We would select the nays here, but of course we're not going to do that. You also want to make sure that all these tabs are switched off when we're doing this. Now we want to go down to load firmware, and where it says local down there. So if I click that and then navigate to that nays file that we downloaded there and press open, and now we need to click flash firmware down here. You can see there it's saying that it's erasing the current version of the firmware on the board, and it is flashing it with the Betaflight firmware. Okay, it says programming successful, so now we should be able to connect to the board. So if we take our mouse and click the connect button there, you can see we have connected, and it's really fast. Actually, it connects really fast. And I have the quadcopter on the desk here, and if I move it around, you can see there that we are getting readings from it. So the first thing that we're going to want to do is set the quadcopter flat on a desk, and I'm going to calibrate the accelerometer. So if I click that, you should see this image here, this graphic, slightly level out because it was at a slight angle there. And there we go, that has finished doing that. We do not need to calibrate the magnetometer because it doesn't have one. So the next thing that we need to do is go to the ports, okay? So what we want to do is enable the serial RX on the UART2. Now, the reason for that is the Scisky uses an onboard receiver, and in order to enable that we need to turn this one on. You don't turn the UART2 on, that's not going to work, and you definitely don't want to turn the UART1 off. I made this mistake the hard way. If you turn this off and then do save and reboot, you'll no longer be able to connect to the board, and what you have to do is you have to solder a jumper on the bootloader pins on the Scisky. Go ahead and Google that, it's on RC groups, it's not a fun process, and then you will be able to plug the USB in and it will basically reset everything. So do not change that at all. What we need to do is turn this on, and then what we need to do is do save and reboot, because you'll see if we move to a different tab and then move back, it will have changed it back to how it was. So we need to save every tab. So I'm going to press that there and then do save and reboot. And that can take just a couple of seconds for it to reboot there. So the next thing that we want to do is go into configuration. We need to change a few things here. Of course, we are selecting this as Quad X for this build. Now, I'm going to turn on motor stop, and what this does is it means that when the quadcopter is armed, when the throttle is at its minimum, then the motors aren't going to spin. Just for indoor use, I like that because it means that we can stop the throttle. Now, the reason why that is turned off is it is useful to have the motors running for their air mode, which basically means that when you are on like zero throttle, it keeps the blade spinning and you get like a really stable sort of drop. But I'm not going to be using that inside. I'm not going to be using the air mode for this example either. I might experiment with it on another video, but not this particular one. I just want to get this thing flying and flying nice. So I'm going to turn on the motor stop. Now we're going to want to turn off this one shot 125 here. That is specific for ESCs, and of course we don't have any ESCs. We're using a brushed quadcopter, so we want to turn that off. disarm the motors regardless of the throttle value when arming via an auxiliary channel. Now I am going to set my arming up on the auxiliary channel 1, and that just basically means that when you press the disarm button in flight, it's just going to stop the motors no matter what the throttle is at. So we've got some more options here. I'm going to leave them at the moment. Of course, disarm the motors, it's like a delay for when you press the disarm button there. I'm going to leave that at 5. All the minimum and maximum throttle PWM values I'm going to leave for the moment because we're going to need to come back to that. What we need to change is this down here. We need to change the receiver mode to RX serial. So just go into there and click on that. All these board alignments, accelerometer trim, we don't need to mess with really. We can trim everything up in the transmitter itself, and we have done the accelerometer calibration, so we don't need to mess with any of that. We don't need to mess with any of this either. We're not going to get like telemetry or anything like that, but we can leave that all the same there. And all this down here we can just leave. The failsafe we want to have on, but we'll want to amend these figures later, so we want to keep that on the Spectrum 1024 as well. And of course we need to save and reboot, otherwise it won't save these settings that we've just changed. Next, we want to go into the PID tuning tab, and we want to change the PID controller to LuxFloat. I think this is the one that's had most of the work done to it. Now we're going to need to press save there because we need to change the rate slightly as well, and it won't let you do that until you have pressed save. So what we need to do is change these values up here, because the yaw rate, if you try and fly it with these rates, the yaw rate is going to be very slow. So I want to change the yaw rate to about 0.6. And then I'm going to change the pitch rate to about 4. It's probably too high, but I'm going to try that anyways. I quite like a lot of throw, so change that to 0.4. And then TPA stands for throttle PID attenuation, and what that does is as you throttle up, it's going to alter the PID settings so that you get a smoother acceleration or height, if you will. So I'm going to change that to 0.3 for now because I'm not too sure what that is going to do. Hopefully it's going to give me a nice ascent and descent rate, but we'll see whether that works. So the TPA breakpoint I'm going to leave at 1500 for now, and then of course I need to press save. On to the next tab, and that is the receiver tab, and you'll see at the moment there we don't have any values coming in here. I haven't got the transmitter turned on yet. We're not going to bind to it yet because there's a couple of other settings we need to change before we do that. One thing we do need to do is change the channel map, because the default one is AETR, that's aileron, elevator, throttle, rudder. 1, 2, 3, 4 is then your auxiliary channels. So I'm using the Devo 7E here. That may be valid for you if you're using a different transmitter, but the Devo 7E is set up the same as JR and Spectrum, which is throttle, aileron, elevator, rudder, and 1, 2, 3, 4. I'm not going to enable the RSSI channel, and all I'm going to do there is press save. Next, I'm going to need to input a command line. Now, the reason for that is the Scisky is a brushed quadcopter, so it doesn't use ESCs, it uses FETs. So we're going to need to put in a little bit of code. I'm not too pleased about this, to be honest, with the setup, but you can use this video to show what you need to do. What I found was at this point I plugged the battery into the quadcopter and the motor started spinning up, and that is because with these default settings it's expecting to have some ESCs, and of course we don't have any ESCs. So what we need to do is go to this box down here, CLI, which stands for command line interface, I would imagine. If we click into there, and what we need to do, I have got the command already in my clipboard if I do Control V there. So if I press enter there, and that is basically just telling the Scisky board that we don't have any ESCs and the motors won't spin up when we plug power into it. Now, this is a mistake I made. I just figured that it auto saves it. You don't. You have to type in save there, and then that saves it and it reboots. And now we should be able to plug a battery into it. But I'm not going to do that yet. what we can do now is we can bind our transmitter to the receiver. So I'm going to go back into the receiver tab. Now, as it's rebooting, it does take a while before it reboots, but there we go, it has gone back into that screen. So what I'm going to do now is turn on my Devo 7E, and I'm going to attempt to bind to it if I have done everything right. Now, I found that it does take a while to bind. It takes usually 3 goes for me for it to bind. I'm not sure why that is, but it's not too much of a problem. Maybe I'm missing something, but yeah, it doesn't bind on the first go for me. So the Scisky board, it goes into its automatic binding mode after 10 seconds, and the light on it flashes really quickly. So I'm just going to go into the options here on my Devo 7E, and I'm going to press the bind button. There we go. So the light then switches off for a while and then switches back on to say that it is bound. Now, you can see there the PWM values have changed, but I'm not getting any readings at all. So I'm going to try and bind to it again. And again, the light turns off. And there we go, it's bound. So you can see, I don't know what that's about. And you know, other people have reported that that doesn't happen to them. So I don't know if I'm doing something wrong, or maybe it's a setup in my Devo 7E. I don't know. But anyways, we do have a reading, and so if I just change the throttle there, you can see that the minimum throttle is 999, or around about 1,000, and then the full throttle is 2,000, and you'll find that that is pretty much the same for all my other axes. So 1,000 on the roll, and then 2,000 at its maximum, same with the pitch. So we're going to get the full resolution on the sticks there. I've also got my auxiliary channel set up as well. So one last thing that we need to do is, now that we know our minimum and maximum PWM values there, so on the throttle we have 1,000 all the way up to 2,001, we can then go back into the configuration and change those. So the minimum throttle I want to set at 999, the midpoint stays the same, the maximum throttle, I think the most it's going to let me do is 2,000 anyways, and the minimum command I'm going to set at 999 as well. So if we then scroll down to the failsafe, I'm going to reduce that to about 960, something like that. So we know that our bottom value is 999, and so when we turn our transmitter off, it's going to drop below this figure, and it is going to fail save. So we need to save and reboot once I have done that. So we are almost done here. The last thing to do is set up the mode. So if I go into the mode tab here, and we need to add a arming range. Now I really like how this works. So if I press add range here, what this does is, this is another PWM value, and you'll see if I move my auxiliary switch, can you see there that green slider sort of moves? And what we need to do is, I've got my auxiliary switch down, we need to take these sort of sidebars here and sort of single out the range, so when that green slider is in there, that function is going to be active, and if I flip the switch, it's no longer active. Really like that. It's really cool. So then we've just got our angle and horizon modes. Of course, we've got all these other modes. I'm not going to go through it. There's that air mode that I talked about, which basically allows the aircraft to sort of maneuver while it's not got any throttle. We've got all sorts of things. G-tune, you can it's sort of got like an auto-tune function similar to the APM and Pixhawk. I'm not going to go through that. We should be able to get a nice flight out of this without messing with those. So for angle mode, I'm going to press add range there, and what we need to do is I need to change the auxiliary to auxiliary 2. You see, because it stays there, so if I move this, the same would happen when I move the same switch. So now if I move my auxiliary 2, there you go, that moves into place there. So I'm just going to move those sliders into that range there. Okay, and then you see when I move the switch, it enables and disables. And then for the horizon mode, I'm going to change that to auxiliary 2 as well. And that one I'm going to want on the other slider there. So these two different modes are using the same switch. So when I flick into the top mode on the switch, we've got angle mode, and the bottom we've got horizon mode. Now you do need to press save, remember to do that, otherwise you'll plug the battery into the quadcopter and it just won't arm and you'll be thinking, what is going on here? And that's it, we're ready to plug the battery in and go and do a flight with it. Of course you want to plug back in that 4-pin JST connector, otherwise your FPV gear won't boot up. Okay, let's get and take this thing for a flight. So the first thing that you will notice is there's a slight bit of noise on the video. It's not too much to get annoyed about, but it is always there. I've done quite a bit of looking into this, and the noise is there regardless whether the motors are spinning up or not. And I think it's got something to do with that built-in regulator on the Scisky. Something that's interesting though is it only happens when I have got the battery plugged in. So of course the Scisky you can plug into the USB port and then that powers the board up and of course powers the regulator up that's on board with it, which powers the FPV gear up, and the noise isn't there when it's powered through the USB port. So it's something to do with when the motors are turned on and the just noise is always there. As we reach the 120 meter point already, I sort of got ahead of myself there. Yes, the range is absolutely fabulous with this thing. I expected about 80 meters with that small antenna. Instead, we're getting really good range. I very rarely go further than 120 meters anyways because I fly in this field mostly. So that is a great result, and no video breakup, obviously, other than the noise that's already on there. So as you can see, I have gone into the horizon mode there. We have the two modes. You start off in the angle mode, which is your stability mode, where the aircraft levels itself and you can only go to a certain angle on the pitch and the roll. And then you have the horizon mode, which is this crazy mode that I'm in here, and we can do rolls and flips and all sorts of things like that. It's basically your acro mode. Now, you do have slight self-leveling in the acro mode, in that it knows which way up it is. So if you go and do a roll, it doesn't stay completely in that angle, it will slowly level itself. So I guess the Naze 32 does exactly the same thing. It's the same as the Alien Wii did as well. You can see here just getting absolutely crazy height. Now here I started to do a bunch of rolls and it sort of tumbled out and sort of lost its weight a bit. I think that might have something to do with the wind though. We had crazy wind on this day. Again, probably, I think it was about 18 miles per hour that it said on the weather forecast. It does get worse throughout the flight and throughout the day as well. Now look at this. Look at this yaw rate. The yaw rate I have set up, I love it. It's crazy. It's just so aerobatic and you can just fly it around. It doesn't lose any height whatsoever. Now, it doesn't look like a particularly smooth flight, but it really was. It does fly very smooth. It's just the wind that's making this thing look not so stable. I mean, if you think about it, we have an aircraft here that weighs 41 grams, and, you know, it's just somehow managing to cut through that 18-mile-an-hour wind despite that. I don't think it's as smooth as the Alien Wii, so some of you who subscribe to the channel may have seen my Alien Wii video, which, as I mentioned, I've taken down because it's been discontinued. Out of the box, the Alien Wii, it didn't require any PID tuning. It was just crazy smooth. And this one just seems just not quite as smooth. I mean, it's absolutely perfect, and I want to get a really calm day, if we ever get a calm day, because I think this is going to be as good as the Alien Wii, I think. I think a lot of people will argue that it's better, but I don't know. I really have a soft spot for the Alien Wii. You can't really fly it indoors, and that is its downfall. With this thing, you can fly it indoors. In fact, I was really surprised when I first flew it indoors. I thought I was flying a Hobson board as I do a very low fast pass there. I tell you, it actually caught me out. because this thing is so light and it's got so much power, it covers a lot of ground fast. Probably the quickest quadcopter that I have got built here. Again, I've done a tumble there and it sort of lost its way again. I can't decide if that's a problem with the PID settings or just the wind getting it completely out of shape. Probably just the wind, because in other rolls and flips it's acting pretty consistently. One thing that I like to do with the Alienware was to do multiple rolls in one go, and that's what I was trying to do, and it lost its way there again. Look at this, just it would make you sick, wouldn't it, if you did that for too long? Just a crazy yaw movement there. And I'm not sure how long the battery is going to last at this point, so I think I keep it in moderately close. No, I'm going to fly a bit further as well. That's the one thing that I haven't got on this. Obviously, I had that video where we added an OSD to it. And you can see there that I'm losing the FPV picture, which I thought was unusual, and it is unusual. That's a sign that the battery is actually cutting out, which is a nice warning because I don't have any other warnings. And so I fly it back to myself here, not sure how much further it's going to last. I certainly don't want to walk across this muddy field. So usually what I do is I fly behind those trees, fly through them, and land next to myself. I don't make it to that, and what you'll see here is as I go over this hill here, we turn around, and the picture really starts to get sketchy, and it's completely lost there. And it comes back as the voltage is brought back from the motor's no longer spinning, but the battery's definitely gone there. Here's a video where I show the extreme angle in the angle mode there. You can't go any further than that. The next video, I thought I owed this to FPV Hobby. This is the picture with just the USB cable plugged in, and you can see there we don't have any artifacts on the screen at all. It's a very good camera, this, at 0.6 grams. Of course, with that wide angle lens, it's going to be more around the 2 gram mark, but absolutely incredible. So here I have got some indoor flying, as I mentioned. This is a really good feature of the Scisky. It is really nice for flying indoors, because actually that's really why I built this aircraft. Now, you're not going to be able to do any of the acro stuff. You're not going to be able to do flips and rolls inside. That is completely just for outside, but it is really stable for indoor flying. It doesn't drift at all, and that is a big problem when flying indoors, is the slight drift that can make you bash into objects, but again, that isn't a problem with the Scisky. Another thing I never needed to do was add a Wi-Fi booster to it. I mean, my range is just brilliant with this thing. And the last video is some flying outside. So one thing I haven't mentioned much about this camera, but it is a low lux camera, which means it works in low light. And you can see here, it is near pitch black. I can't get this view with my eyes. If I look out to the street, it is really dark. It's really patchy. You certainly don't want to be out there long in it, but with this camera here, it's picking up somehow. It's getting the light through. So I mean, that is just great as well, because obviously in the winter for a lot of folks, very difficult to get flying in when it is light, because we don't have much light. So one thing that I do have here though is an incredible amount of wind blowing the thing about. In fact, it was almost unflyable. I think the winds were at about 30 miles an hour here, and it does look really shaky and unstable, but you cannot see the conditions it was having to deal with. I can't believe that it managed to fly at all, so really impressed with this. So in general, yes, it's a fantastic controller, but not sure about this noise on the camera. I might have to throw in another regulator there and see if that improves things. It's not enough for me to be really annoyed about, because it's a good enough view for me to be able to fly, and I don't notice it when I'm flying. I more notice it when I watch the footage back there as I do a slow flight down the street. So yeah, I don't think I like it as much as the Alienware, but it is definitely a really good substitute, and I think people will disagree with me there because they love clean flight. They love how they can integrate that with their 250 size racer. So there you go, that is my build video of the Scisky and a micro FPV quadcopter. Thanks so much for watching. Please continue to subscribe. Cheers.